Hello everyone, welcome back to another video for the series. I'm Enoch here and today I brought an algebra problem from IMO. I think I didn't bring lots of problems from functional equations and to be honest, I don't really like them. So these days I'm just praying like please, uh, I don't want any problems related to functional equations in KMO. I only want inequalities. Yes, but I also need to study functional equations, so I brought it. And it's late, day 50 today, so like we're halfway there. So it's the 50th video. We have another 50 videos to go, and I have 49 days, including today, until KMO, which means I have less than 49 days for AMC. So maybe I might make more videos about AMC, like not so that's distinct from this series. And yes, please pray for everyone who is taking AMC, KMO, and other med competitions, and good luck to everyone who is preparing for it. Okay, so without further ado, let's start this problem. So first of all, I'm going to introduce like what I did first. So first of all, I assume that A equals B equals C equals 0. Then we know that f of 0 plus f of 0 plus f of 0 equals 2 times f of 0. Therefore, f of 0 equals 0. Okay, and next thing that we can do is let b equal c equals 0. Then a can be anything. So in this case, we have f of a plus f of 0 plus f of negative a equals 2 times f of a. So we have, this cancels out, and when we move this, we have f of a equals f of negative a. Therefore, f of x is even. From here, I was stuck. I was not able to continue, but I found that the official solution is like brilliant. It's just brilliant. So we know that rearranging these terms, you know, the a equals negative bc over b plus c. Now let's think about it. If we're going to talk about a comma b comma c. So it can be like I'll say 2x comma negative x. That's for b and c. Then obviously a should be x cancels, yes. But if we actually substitute it here, we have f of 0 plus f of 3x plus f of negative 3x equals 2 times f of 3x. And let's just tell that f of x is even, in which we already have it here. So cross that out. The second case is when this is equal to, because we did 2 and negative 1, why don't we try 3x and negative 2x? Then obviously a should be 6x. Then let's substitute it. We have f of 3x plus f of 5x plus f of 8x. Oh, negative 8x, but anyways, f of x is even. We can write it as f of x equals 2 times f of, add them, we have 7x. So let's say that let f of x equals alpha x squared plus beta x to the power of 4 plus dot 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 until we have omega times x to the power of n. Okay, then rewriting this equation, we have beta times 5x to the power of 4 until omega times 5x. Oh, why is it 5? It's 3. plus, oops, 3x to the power of n plus 5x omega 5x to the power of n plus 8x squared plus beta 8x to the power of 4 plus plus. When we add all of them, we get alpha times 3x five x squared 8x squared all the way until we have, and n of course is an even number. Wait, I forgot. Yes. And let's rewrite this. We know that this is also equal to 2 times what we substituted here. So alpha times 2 times 7x squared plus plus. Now, for this to be true always, because alpha, beta, gamma, not gamma, alpha, beta, delta, and so on until omega, because they are all fixed number, so they're not a variable, they're constant, we must have 3x to the power of something, k, plus 5. We just need to find k that satisfies this, that are even. So if we find k's that that satisfies this one, then we can replace that. So because we know that f of x is equal to this, we can actually find f of x by doing that. Because these two, if we find any k that satisfies this one right here, this one right here, this is an if and only if condition with the one that we see right here and here. And also we can add multiple k's. So we can, what I mean by multiple k's is that we can write all the k's that are true. So because those, are they? Because those two are if and only if condition, I think, because this one and these are the same thing, and if we find k, and if and only they're the same thing. So if this and that, if this and that, yeah, so it is indeed if and only if condition. So if we find k, then we can also find f of x. Let's divide it by x to the power of k on both sides for simplicity. And actually, to be honest, I was so mad when the official solution said that k must be less than or equal to 4, but because the solution did not provide more information about it, so what we should do here is divide by 7 to the power of k on both sides equals 2. Now if we just find k that satisfies this, then we know that, so if we find a k that satisfies this, we know that the k's that satisfy this equation must be less than that number. So let's randomly try like 5. This is quite painful, but 32, 4, 8, 0, 2, 0. The reason why we can try 5 is because, like, why not? It's not like bad number. 7 to the power of 5. I need to do this. This is equal to minus 343 times 5, 5, 1, 2, 1, 7. This is equal to 7. Please tell me if I made a mistake. I haven't checked this with calculator yet. Dividing. Oops. Wait, this can't be it. Oh, of course. Of course. I forgot a 0. Two, 3, 3, 2, 7, 6, 8. And let's double this. So 14, 6, 30. No. We need to try 6. Haha. Okay. So 8 to the power 6 equals 512 squared equals 6. Wait, is it 3, 1? So we have 4, 4, 1. I hope this is right. Not sure if this is right though, but 7 to the power of 6. Just multiply 7. We have 49. 5, 5, 42, 7, 4, 11. Let's multiply this by 3. We have 7 to why 3? 2. Great. We know that this when we multiply it by 2. Wait, what? How can this be smaller than that? 0, 0. 0. 0, 0. 6 and 25. Oh my goodness. So we have 2 like this, and we know that this is less than that, right? Yes, it is right. So we know that k must be less than 6. Therefore, the only k that works is either k could be either 2 or 4. Wait, can 0? No, 0 doesn't work, obviously. So let's try 2 and 4. It's quite painful, but when k equals 2, we have 9 plus 25 plus 64 equals 2 times 49. Is this correct? Okay, so 80, 89, 89, 98. Nice. The second case is when k equals 4. Oh no. Okay, so 3 to the power of 4 is 81 plus 6 to 5 plus this is equal to 12, so 496. Yeah. 2 times 7 to the power of 4 is 343 times 7 is 4. 2401. So this is equal to 4802. And this one is equal to 11274. We have 2084. Yes, so indeed this works, and we know that k must be either 2 or 4. And as I mentioned, because we can write f of x is equal to alpha times x to the power of 2 plus beta times x to the power of 4, x to the power of 4, and that's because alpha can be 0, beta could be 0, and it could be any other number. So and also it will still satisfy because we took a look at on individual terms, and because it works individually, it should work on the other terms too. Yeah, because we're just adding, I think. No, wait, does it? So, this works. Yeah, I think it still works because we're just it still works because we're just adding more terms. Yes. So this should be our final answer. Thank you so much for watching this video, and tomorrow I'll come back with another very fun and interesting problem. Thank you and see you tomorrow. Bye. Oh wait, I forgot to include condition. We're alpha and beta real number. And thank you so much for watching this video, and see you tomorrow. Bye.